No, I thought we were still finishing chapter whatever.
Okay, so if I have, this guy is called. What is the name of this chemical right here?
Are you asking me?
Yeah,
Oh, I have no idea.
I said I was going to start with Kelsey.
I know, it's because you like to pick on me. I don't know. Are you talking about like diatomic, or is that what you're talking about? Like those?
I want to know the name of the chemical. What is it called? Like, you know, baking soda is also called sodium bicarbonate. This is called what?
I don't know. Can I phone a friend?
Yes, you can phone a friend. Which friend are you going to phone?
Methane?
Who said it? I heard somebody say it. Come on.
Where's Fabian at?
Am I hearing things? Eric, the next person I like to pick on. Eric with the C, and then we'll go to Eric with the K. But I know Eric with the C is going to represent.
What was the question? What was the name of that?
What is the name of this compound?
Shit, I don't know. Is it like are we naming the alkane and all that, or just the name of the?
Oh, like that?
Yeah, that it has a name, right?
So is it butane?
Methane. I don't know.
Nope, it's not butane.
Butene?
You said
Not
methane.
butene. Are there 4 carbons?
With the Y, because
I don't
there's
know.
at least 3 bonds.
No. How many carbons do you see up there?
4.
I may be blind.
One.
There's
I see
one.
1 carbon.
Yeah.
So what am I going to call something that has 1 carbon?
Methane.
Who say it again, please?
Methane.
Methane.
That's
There we go.
You know, it got me confused with that 4.
Yeah. Because there's an H. There's 4 H's that are with it, right?
Yeah.
Methane. That sounds like an excuse.
Nah, my bad. That was wrong then.
Okay, so what is the, do you guys remember the order? So if I have 1 carbon.
Methane.
Methane.
Okay. So 1 carbon. The prefix is meth. 2 carbons.
ETH.
F.
F.
And then
3 carbons.
Prop. 5, 10.
4 carbons.
Butte.
But Butte.
Butte.
5 carbons.
Pent.
Six carbons.
Hex. X. E-E-X. I do not say.
Hex.
H-E-X. Yes.
7 carbons.
Hep.
8 carbons.
Oct.
9 carbons.
None. None and
10 carbons.
Dex. It's Dex. On deck.
11 carbons.
On deck.
12 carbons.
To deck. To deck.
Okay. Piece of cake. So what if I have this?
It's a double bond. What in the hell?
I'm just drawing all my H's. Hold on. Relax, breathe a little bit.
That's 5.
Yeah,
I
it's
don't know
fine.
if you add. Do you add a double bond?
1, 2,
Or you
3.
just count it as 1?
So the end would be ENE, but it's got 5 carbons, so it'd be pentene.
Yeah.
That's right.
It looks like a worm.
That's 4. That's 4. That's 4. Okay. So we said pentene.
Mhm.
Sounds good. Okay, what about this?
It would be
Heptine.
heptine.
Heptine with the Y?
Okay.
What if it has a triple and a double?
Ah, that is what we're going to get into today.
Oh,
It's called priority. So double bond has priority over single bond, which we see here. That's why we put an E and E. If it has a double and a triple, the double has priority over the triple.
why?
I don't know. Somebody thought it would be cool to do it that way at some point.
So no
So,
matter-
but I'll show you how to keep track of the triple because you got to let people know what it is, right?
So double bond is like the king.
Double bond is the king of the al or of just the hydrocarbons, straight hydrocarbons.
Okay.
Yes. Okay. So priority wise, so we'll start talking about priority. We'll make another list over here. So we have low man on the totem pole is the alkane, so we'll put him last. So it's double bond. So it's alkene, alkyne, and then it's alkene. Alkane, sorry. Okay. So this guy has priority over this guy, over that guy. There's going to be more, so there's more to come. Okay, so let's talk about this a little bit because I want you to understand how to name carbons. And do you see how drawing all of those C's out and all the H's is out? That's a pain in the butt, right? Because I'm still working on this one. I haven't finished all of the H's that would be here, right? So that would be an H, that would be an H, that would be an H, that would be, oops. Come on. And especially if we're doing it via Zoom, we'd be here all day for me to finish structures. Okay, so let me show you how a way that we do it to make it easier for ourselves. So this is one way, which is the long way. The other way is I'll draw the one that's at the bottom since it's bigger. So for every carbon, if it's a triple bond, we just draw the triple bond. You don't use any of the H's. So that represents a carbon bonding to another carbon with a triple bond. Then, oops. Then we draw that single bond. Then we go bend for the other single bond. And then we go for the double bond. We draw a double bond. Then we go bend for the single bond. Then we go bend for the other bond. Okay, so every end represents carbon. So if we count how many carbons this guy has, we have 1, 2, 3, 4, 5, 6, 7, 8. Although I counted too many. 1, 2, 3, 4, 5, 6, 7. I gave me too many bonds. Oops. So that's 1, 2, 3, 4, 5, 6, 7. There we go. Okay, so if I have, we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points. So what would be the name of this hydrocarbon?
Deck. No.
That's right. Undeck what?
Bean.
Undeck. Okay. Okay, so pretty simple, right? But how do I distinguish between this guy and that guy? Do I call them the same thing?
Yeah.
They're going to behave differently, so they're going to be called something different. Let me show you how I would do that. The way that you would do it okay. So the way that you would do it is the side that has the priority structure with the smallest number. So we count the carbons, we number them 1, 2, 3, 4, 5, 6. Oops, skipped one, sorry. 6, 7, 8, 9, 10, and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So then what we will do is we tell where that double bond first starts. So the double bond starts at the 1 carbon, the first carbon, then goes through to the second carbon. So we would call this guy down here 1-un. Decking. Okay.
Count backwards from the chemical, like to count the carbons. Do those count from the end to the right or to the left?
It depends. It depends. So if the, and I'll show you that here with the other one up here. So you always want to give it, you want to give the priority functional group the smallest number. The one who has the highest priority always gets the smallest number that we can give it. So you always start at one end or the other end, and you count the longest carbon chain. So 1, 2, 3, 4, 5, 6. That, oh, 5 on one side. If I went the other way, it would be 1, 2, 3, 4, 5, 6. So I have 5 going one way, 6 going the other. So then I would number it this way: 1, 2, 3, 4, 5. Because that gives me the smallest number for the double bond. Double bond has priority over single bonds, so we start off with that one. Okay.
And if it was all single, then it wouldn't matter which way you numbered it.
Yeah, it wouldn't have mattered which way I numbered it.
All
They're
right.
all single. Okay. Unless I had something coming off of the single, which I'll show you here in a second. So this guy would be called what? Where does the double bond start? Finish numbering.
1, 5.
Okay.
So it would be
5-1
Okay. Piece of cake.
Oh, I see.
Can you repeat that again, please, Henry?
Sure. How about we go over another problem? Let's see, we'll go.
No, repeat this because I'm actually writing this one down, please.
Okay. So you want to go and determine the smallest number for the structure that has the highest priority. So double bond has a higher priority over a single bond.
Yeah.
So we want to count so that it has the lowest number where that double bond is going to start. So we count 1, 2, 3, 4, 5. So it starts at the 5th carbon. So then we would say 5 undecane.
Okay.
Okay. So if I went the other way, it would be at the 6th carbon. That would be 1, 2, 3, 4, 5, 6. It would start at the 6th carbon. That number is bigger than the number, so I wouldn't start that way.
Got it. Thank you.
Okay.
Always the shorter side.
That's
Sure,
right.
slide.
To
Okay.
go with the smallest number and the highest priority?
Yep.
All right.
Okay, so let's say I have this guy.
And this is the shorter way, right? You said? Instead of doing it that.
Well, do you want to, here, you can write out all those carbons.
No,
for
no,
me.
I know, but I'm just saying that way I can write on my notes and stuff like that, so I already know.
Yeah.
So when you're talking about priority, you just mean the one with the biggest bond, unless it's alkane, kind of.
Yeah. So this is your priority list right now. So your alkene has priority to your alkyne, which has priority over your alkane. So this guy is the low man on the totem pole. So he gets screwed. Okay?
Single bond is last?
Yes, the single bond is the lowest on the totem pole.
Oh.
Although there's a few of them that are going to be, well, there's one that's lower. So, okay. So what are we going to name this guy? Let me fix it. It looks horrible. This is a triple bond.
Would it be non?
1, 2, 3, 4, 5, 6, 7.
Oh, wait.
Peptide.
Oh, I drew it wrong, so I added an extra hump.
Would it be 3 heptine?
1, 2, 3. Yep. So it would be 3 would be the smallest number, right? 1, 2, 3, 4, or
Yeah.
1, 2, 3. So it'll be 3.
3 dash 1, 2, 3, 4, 5, 6, 7. 3 dash head 8.
Okay. Okay, so now let me introduce you to some other things. One, two, three, 4, 5, 6. Okay, so if we have something like this, this is called a branch structure. Now, the way branch structures work is you want to try to identify the longest carbon chain that you can get. So if I start here, we'll write this in brown, reddish brown. 1, 2, 3, 4, 5, 6. If I start here, it's 1, 2, 3, 4, 5. If I start here again, 1, 2, 3, 4, 5, 6, 7, 8. Which one is the longest carbon chain?
The top one.
8.
Okay.
Green.
So our root is going to be, are there any double bonds here?
No.
No.
So our root is going to be, A and E, root meaning the last letter at the end. A and E and E, or Y and E?
Yeah, Annie.
And,
E and E. Okay. And what is going to be my prefix?
Oct.
octane.
Okay. So this octane, if we chose this route, right, the green route, on the 1, 2, 3, 4, on the 4 carbon, it has a single carbon. So what we do when it has a single carbon that is kind of on its own, we put a Y, L at the end. So 1 carbon, the prefix would be what?
Meth.
So we would say methyl, right?
Meth.
So this guy would be called come on. It lets me write. So it's 4 methyl octane.
Okay, where did you get methyl from again?
Because we only have a single carbon that's coming off of that longest chain. There's 1, 2, 3, 4, 5, 6, 7, 8. That's my longest chain. I have 1 carbon coming off of it. Right here. I'll draw circle in pink.
1 carbon coming out from 4.
Off of 4. Yep. So that's where I get the methyl from.
So any individual carbon that's coming off of a long chain, it's automatically going to have a YL on it.
It's going to have, well, if it's only a single carbon coming off of it, it's going to be a methyl, right? If it's a double carbon, 2
Yeah.
carbons, something like this, that's going to be an ethyl. 1, 2, that's coming off of that, the 4th
Okay.
carbon. So in that case, I would call this guy ethyl.
Ethyl. Okay.
Because there's 2 carbons coming off of that one. So it'll be 4-ethyl. Okay. So if it's 3 carbon, what is it going to be? Pardon me?
Ethyl?
Oh,
Say it
how
again?
did you get that for again? Sorry.
Is it a
How did you get that for
4-proethyl?
again?
Yes, that's right. It will be 4-propyl octane. Now, somebody asked me, how did I get the ethyl? Or how did I get the 4?
The 4.
I get the
How
4
did you get the
because
4 again?
if I count my carbons, 1, 2, 3, 4, it's coming off the 4th carbon. So you're telling me the location where that ethyl is at. So if I was drawing it and I have this name, I'll give you an example. Let's say we have five propyl. Oops. Actually, five propyl decane. So I draw my decane first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on the 5th carbon, 1, 2, oops, 2, 3, 4.
Can't see what you're writing.
You can't see my writing?
I can.
No. Oh, now I can.
So on the 5th carbon, I have a propyl group. 1, 2, 3. 1, 2, 3.
Nice.
Okay. So 5-propyl decane. Questions?
Professor, I have a question.
Yep.
On the exam, how would you ask the question for these things?
Draw the structure for 5-propyl decane.
And then is it only going to be methylene and ethylene or whatever? Methyl and ethyl?
No, it's because it's the same roots. If there's 20 carbons, right? So then whatever the longest chain is, there's 20 carbons, then you call it that base. And then if it's 7 that is on a chain, then you'd call it heptyl, right? So it just depends on how many carbons you have. This one has 3, 1, 2, 3. So that's why we call it propyl. This one has 2, 1, 2. So that's why we called it an ethyl, right? So the first thing that you want to do is identify your main carbon. That's going to give you your root, that last name, right? Then the side chains give you what you have in the beginning. Okay?
So the root is always going to be the end.
That's right.
It's your longest chain, and then the break off is going to be first.
Yeah. So then your break off always goes first. Yeah. So your longest chain gives you the name, the last name, the big name, right? And then the chains give you the ethyl, you know. Okay? Questions?
I have another question. So you have to count. Professor.
What is the
Professor.
question?
Okay,
I'm confused.
I'm
What are
sorry.
you asking me?
What I'm asking you is, so we have to count the long chain first before the long one, because I can see 1, 2, 3, 4, 5, 6.
So here, 1, 2, 3, 4, 5. 1, 2, 3, 4. So this would be the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? That gives me my longest chain. If I started here, let's put this in a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's too short. If I went the other way, 1, 2, 3, 4, 5, 6, 7. Way too short. Right? So you always want to find the longest chain first.
Okay.
Okay?
Thank you.
Let's try this one more time. Yes.
Dr. Eric.
Yes.
Oh, you cleared it up. I got a question though.
Okay. What is your question?
No, you just cleared it up because I wanted to ask when you are counting the carbon from the chain at number 0.5, do we include the carbon when we're counting the propyl or butyl? I'm trying to get confused there. Because when you count from the chain 1, 2, 3, 4, the fourth carbon is at number 5 from the chain.
That's right. 1, 2, 3, 4, 5. Right?
No, from here, from this direction, from the chain down. 1.
So if I started here?
No.
Right?
When
if I started down here.
Okay.
Is that what you're saying? If I started where the orange is at?
Yeah, I'm trying to see if it's gonna be propyl or butane. 5 butane.
So that's, oh, you're asking me how big is this carbon? That's 1, that's 2, and that's 3.
Okay.
This carbon you don't add to it. It's the carbons that come off of that carbon.
Okay, that's why I
1,
was
2,
thinking.
3 that come off that carbon.
Yeah, I was thinking this one that carbon at 5 should be included.
Yeah, you don't include that one. No, that's part of the main chain. So this is all main chain.
Okay.
Main chain right here. Okay, and then these are your side chains.
Side chain. Okay.
Yes, and that's what they're called. They're called side chains.
Can you tell me what the main chain gives you again? It's the meth, eth, prop, and all of that, right? And then the side chain gives you the...
The side chains can give you the same thing. It's the same prefix. Side chain has 1, 2, 3. That's propyl, right? Prop, and then you put YL because you're telling me it's a side chain. It's not a main chain.
Oh,
so
okay.
that YL means that it's a side chain. Okay. Let me get this out of the way.
I have a question, Dr. Henry.
Yep.
So do you see how on this one you right here you did like it goes up, the side chain goes up because it's on the top?
Right here. And the first one?
Correct. And then on the second one, the side chain goes down because it's on the lower carbon?
Yeah.
Does that matter when you draw it back out long ways?
No, it doesn't matter. It's essentially the same. I'm just making a hot mess, you know? So.
Oh, okay.
You can make it nice and tight, you know? Oops. I don't want to erase it all. Okay, questions, concerns, Cash? Okay, so let's add a little bit more. Okay, so if it's a single bond, you saw we always use that YL.
What is the YL again?
The YL means that it's going to have a side chain.
Okay. I have a side chain.
Whenever it has a side chain, huh?
Yep. It's your side chain, yes.
So it's going to be a non.
Sorry, it's just because I haven't been able to come to class as often as I would like from my family matters. So I've been behind from class for like one class.
Okay.
I'm catching up on the videos.
Okay. Good. Good. Hopefully they're understandable.
Yeah, I'm trying.
Okay. So what is the main chain here?
Non.
Okay.
Is that a double bond or what is that?
Nope. It's two single bonds coming off of there. So it's two carbons coming off there. I'm going to show you how to name this guy. Hold on. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you said it was
Non-A-N-E.
E-N-E or A-N-E?
A-N-E.
A-N-E. Okay. No name. Okay. So here, where is the carbons? Where are these carbons coming off of?
The third one.
The third one. So here, since there's two, are they two single carbons? So I have one. What would be one coming, the name for one carbon coming off the side? Called? Meth?
Yeah.
Meth what?
Methyl.
Methyl. Methyl. Okay. Now I have two of them that are coming off of there, right? So the way that I could write that is I would call that guy, because there's two methyls coming off. There's one, there's two. So then I call that 3-dimethyl no name.
Di means two.
That's right.
I see.
So I'm gonna draw purple here. Okay, so what about this guy?
Holy crap. Then that still be a no name.
Okay.
Be 3.
Yeah.
Oh, I don't want to get ahead of him.
3.
Dimethyl.
Dimethyl.
And then 5.
Methyl.
No.
Bimethyl, yeah. Is it that?
I'm just guessing.
That is correct.
Ooh.
1, 2, 3, 4, 5. Yep. So 3-dimethyl, 5-methyl, no name. Okay. Or I could call this 3, 3, 5-methyl. Sorry, trimethyl.
How do you know then that it's di?
Trimethyl. Tri. Meaning that I have 3. What was that?
You answered my question.
Okay. So 1, 2, 3. So yeah, I'm telling you I have 2 at the 3, 1 at the 5, and it's a trimethyl.
Oh, okay, okay.
Wait, repeat that one more time. You have 2 at the 3.
2 at the 3, 1 at the 5, and so there's a total of 3 methyls. So I call it trimethyl.
So would it be the same if you would have answered it the way we answered the first time?
So it technically would be correct, but it would be the least efficient way of writing it. So it would be
Okay.
correct.
told us that scientists are lazy, so they don't like to write.
Exactly. Yep.
Would this be the preferred way to write it for the test or on homework?
Yes,
could
this
we-
is the preferred way to write it for the test.
Oh. We would get point stock if we wrote it the other way.
I would give you a couple of points, but I would still dock you a little bit. Yes, I would.
Okay.
Because remember what she just told you, Kelsey. What did Kelsey say?
Scientists
are lazy and they don't like to write.
That's right. Okay, so
I have a quick question.
Yep.
So the reason why the trimethyl, the dimethyl, the tri and di are there is because that's the total amount of chains, right?
that's right.
Okay, thank you.
Okay. Okay, so what is the main chain?
Okay.
octane.
Okay, so who has priority here? And tell me, what do I have hanging off?
Double bonds.
I have a double bond? I don't see any double bonds.
No double bond.
No double bonds.
Single.
They're all singles.
I would say the 2, the one attached to the 3, the third carbon.
So you're saying this one here? So you go 1. You're saying you want us to start counting from there. Is that what you're telling me? It's 1, 2,
No double bond to even go off of, so how do you know which way to count?
3.
Oh, it's the longest.
Be the other one
Wouldn't it be the other one?
because it's shorter.
Order to what though? The first die?
To the first carbons, the chains.
We got this.
Because the first one goes 1 and then 2.
Yeah. Who decided you could count backwards? That's stupid.
Okay, so it's 8 both ways. If I go here, what is this structure that's coming off of this 3, the pink 3,
Is
or
it
the green 6? It's a what?
ethane?
And then
Is it an ethane or is it an F?
Ethyl.
Ethylene?
Oh yeah, ethane.
It's an ethyl.
Ethylene.
Side chick ethyl.
Okay, so and then what do I have coming off of the 2 carbon here, or the 7 in pink?
You have di.
Methyl.
Methyl. 2
There's
methyls.
One.
Dimethyl?
Dimethyl.
Dimethyl.
Okay.
The other one's ethyl because it's attached to it, right? Like it's connected, and this one
Yeah.
it's separate.
Well,
Okay.
yeah, because there are 2 carbons. 2 carbons there. This one only has 1 and 1. They're separate from each other. Okay. So, who has priority? Who do you think has priority? The bigger one or the smaller one?
Smaller one.
Small.
Smaller one.
No,
Nope.
I was the one
Nope.
closest to 1.
The one closest to the 1?
Yeah.
Nope.
No?
So it's kind of like life. The bigger person, whoever has more money, right? So here you have 2 carbons. This guy has 1 carbon. So this guy wants to have the lowest number. So the guy who has the highest priority between the two. This one is 2, this is 1. This guy, the ethyl, has higher priority. So you want to name it with the lowest number that it can get, and then the methyl. So then the answer would be
What?
it would be 3 ethyl seven dimethyl okay.
So just a quick question. So the reason you're putting a double 7 in your answer is because the side chain right here is 2 of them at 7, correct?
That is correct. And di tells me there's 2 of them.
Got it.
You would keep the die? It's like redundant sentence.
Yeah, you keep the di. You're just telling, because you also have to tell me where it's located, because it could be, it could be 7, 4, or 4, 7 dimethyl.
So that tells location of the word.
That's right.
What do you mean it could be 4, 7?
Okay, let me write it down. We'll type it down and then you can draw it.
Oh, like there could be 2, like 1 coming off the 4, 1 coming off the 7?
That's right.
I got you. I thought it was counting it, like 7 and 7 was counting it. You see how there's 2 7s, so then you'd have like 1 coming down, the other one coming down, and then die would be 2, so that's why I thought it was redundant.
Okay, so draw this guy.
All of us.
We draw that one right there, Dr. Henry? Dr. Henry?
Yes.
We draw, okay.
Yes.
Sorry, I didn't hear that.
Do you want me to say it again? Yes.
I couldn't
Draw
hear
this
it.
guy.
Wait, so the 3 and 4 have 2 coming off of them, or 1 apiece? It'd be 2, right?
The 3 and the 4 have, no, they each have 1 coming off of them, right? So there's 2. I'm telling you, there's 2. If there were 4 of them coming off of there, then it would be 3, 3, 4, 4 tetraethyl.
I got you. Okay. Okay.
Okay, cool.
But how do you, how do you know which way to count?
Your control. Who has priority?
Can you explain that
Or the
part,
methyl.
please, Dr. Henry? The one where you, like the first example where you explain why the 3 comes before the 7?
You're saying up here?
Yeah, 'cause
Yes.
I'm thinking,
Can you explain that
Pause.
part again for me?
1, 2, 3, right?
Uh-huh.
How big is this? How many carbons?
Two.
That side chain. It's 2.
So there's
How big
two.
are these side chains?
Just one.
They're just 1.
Okay, so
Is
there's
2
one.
bigger than 1?
Yeah.
Okay, so the bigger
And then
one
2
comes
has-
first.
That's
Got
right. The older child has priority.
Hey, Dr. Henry, on the first one right there, on the 3 and then the 4, do it always have to be opposite sides like you're doing it right there? Or can it be facing down? You know how you have it?
Yeah,
up?
no, that's fine. The way he's doing it right there, that's fine.
Oh, okay.
Yeah. It doesn't
Oh, I
have to
thought
be
you were
facing
doing that.
down. Yeah, actually, it's the way that you have it as it going down. That's the way that you want to do it. This guy, you
Oh,
want to go
okay,
up.
okay.
Because if it goes down, it kind of gets.
Yeah, because I have all of them down.
You said the bigger sidechain has priority?
The bigger or the longer side chain has priority. Yes.
Okay.
If it's just a hydrocarbon, we're going to get into other things. Don't worry. Then I'm going to make it even more complicated.
Put something on the screen. I don't know if I get it right.
That is correct.
Correct?
Yep.
Yep.
Okay, so you guys got it? You feeling it?
No.
No? What do you mean by no?
Sorta.
Sort of?
I'm backwards.
Dr. Henry,
Yep.
I usually come to the Tuesday class, so I'm like so lost because you haven't taught us this yet, right?
No. I haven't.
Okay.
I feel like it's easy, but you just have to read carefully. Because
Yes.
I did get confused on the second one, on the 6 and the 7. I put that double instead of the single.
Yeah.
I did get confused on that.
Okay, so let's see.
And then what is the simplified form you want that in? You were saying you preferred it in a certain form?
That's the
I
preferred.
think that is the simplified
Yeah.
form, right?
That's the simplest one.
That is the simplest. Otherwise, you can write out all of the carbons and the hydrogens that go with it. So like there's 3 hydrogens around this carbon, there's 3 hydrogens around this carbon, there's 3 or
And the
what
other
was that?
the example that you showed prior to this one that you're doing now, you put all the numbers in front of the words. Is that how you want it, or did you want the number, word, number, word?
No, I didn't put all of the numbers in front of the word. It was just that we had 3 methanes, right? We had 3 methyls, so it's trimethyl. Look at what you're given, you know? And then the way that you would do it based upon that would be on alphabetical order. So E comes before M. And then your root always is the A and E, right? Or that last part. Okay, so what if I had this? That's a double bond. Okay. So what would I name this guy?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay.
Undek.
Would the last part be a 5 undecking? E N.
Decane, yeah.
Okay.
Or-
So the last part would be undecking.
Undecking.
Okay.
Decane. There's a double bond.
And where's the double bond located at?
1, 2, 3,
4.
4.
Okay. And anything else?
5, 6,
1, 2,
9.
12.
2 methyl. Or
2,
1,
3
3
dimethyl.
methyl.
1, 2,
Methyl, 3 methyl.
1, 2 dimethyl.
No.
4, 5
2 methyl.
diethyl
3.
undecane.
I'm trying not to laugh too hard. You guys are cracking me up.
Let me try it.
Everybody just throw answers out.
1,
Let's confuse him.
2, 3. Dimethyl. 5, 6 diethyl 4 undecane.
Okay. So,
Mono solo.
Say that one for extra credit in the test.
No.
you're like, no. This is an easy one. It's gonna get harder. Don't worry.
How come you wouldn't put 2, 3?
Sorry, my bad. It's
Okay.
2, 3.
I was like, why wouldn't you put that first?
I just like 5, 6.
No, but why wouldn't you put that first?
Alphabetically, E, M.
Oh, I didn't know if it went off of carbon.
So now we do alphabetically now.
I thought we were going off of
Yeah.
carbon.
Oh no, it's like we're going backwards. You don't write as much. Now it's alphabetical order.
Yep.
All these rules.
The 5 and 6, Dr. Henry, go first because there's 2 attachments, correct?
And they have
Nope. The 5 and 6 go first because it's diethyl.
Diethyl. Okay.
E is less than, is
1.
comes before M. E becomes before M. Like, alphabetical. There we go. It's rough. It is rough. Okay, questions?
So it's only when the first letter is the same that you go in alphabetical order, between which one comes first, or is it?
So you always want to try to, the E, this part always goes to the end. That's always going to be at the end. But the way you decide this is decided by alphabetical.
So say if you had the 2 letters at the beginning were not the same. There wasn't D, and it was like A, B. You would put the A before the B,
Yes.
or
Yes, that's right.
don't like these.
Oh, so you're asking me if the suffix, so
The prefix is
the
different.
prefix. So that prefix di, meaning 2. So you're not taking that in consideration. You're taking the ethyl and the methyl into consideration.
oh, okay.
Okay, ready for your next one?
Oh, hold on, real quick. Hold on.
Going quick today.
You said we're going quick today?
Yeah, I'm trying to get everything down as we're talking.
Boom, 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 boom.
Sorry, I'm fast. It's been a long day. My bed is calling me.
It's not a competition right now.
You said it's not a competition?
No, it's not.
That's a long down.
Got it. Thank you.
Okay. Okay, so let's make it a little harder here. Oops.
Triple bond.
How did you know?
Problem. Could somebody clarify the alkene, kyne, and cane? Like how the order works? Like I know it's supposed to be alkene has priority, but like somebody said double bond, so it was alkene.
Alkane is the one bond. Alkene is two bonds, and alkyne is with the Y. That's three bonds.
Yeah.
At least three bonds.
Let me write that down.
The double bond is always king.
Yeah. And I was gonna ask you this, Dr. Henry. Whenever there's two bonds, you go with which one's the highest, right, or is it the lowest?
Alkene.
Double bond is
It's a double bond.
Double bond has priority.
Okay.
Yeah. And
That's the whole,
So-
the big brother comes first.
yeah, although, yeah, the middle brother in this case. So this is IUPAC nomenclature. So this is part of your IUPAC nomenclature. So this is for organic chemistry. So you also have common nomenclature, which you're going to get a little bit of, right? But not too much, because everybody's moved to the IUPAC nomenclature. With the IUPAC nomenclature, you always think about priority. Who is the most important, right? So the most important is the double bond. I'm assuming they make the double bond more important than the triple bond. In the old days, it used to be the triple bond. That was more important because it was 3. But you're more likely to have a double bond than a triple bond because triple bonds are not as stable. Okay. So, and they're rigid. That's part of the reason why they're not as stable. Okay, oops. I was going to do something with this. Okay, so we have this molecule here. So how would we name this guy? All right, so let me tell you this because we haven't talked about it yet. So we have a double bond and a triple bond, right? Who has priority?
double bond.
Double bond. So we want to make sure our double bond has the lowest number that it can have, right? 4 is the lowest that it can have. Can't get any lower than that 4. So we're good there, okay? So since this is a triple bond, what we do is tell where that triple bond starts. It starts at the 7. So then we're going to do seven dash YN dash. So kyne. So this tells me that I have a alkyne at the 7th spot. Okay. And I no longer have a dye. So and that should be last actually.
Why?
Because it's a Y.
And you don't take the E with it.
What was that?
It's just YN and it's not the E.
Yeah, we dropped the E and we use just the YN. So we have 5-ethyl, 2,3-dimethyl, 7
YN.
YN, ein, 4-undecene.
Damn.
Can you leave it up really quick while I write that down?
Sure.
What does nomenclature even mean?
Are necessary.
Means naming.
Naming. Okay.
What was that?
All these dashes are necessary.
Yes, you want to put them in there because it helps you keep things clear.
5.
So right now we're learning nomenclature.
That is correct. You're starting to learn nomenclature. Because you need to know how to name it to kind of use it, right?
Mhm.
Yeah.
No?
Yes.
Yes.
Okay.
And the 4 attached to the undecene is just saying that there's a double bond on the 4.
Yes, it tells me that there's a double bond that starts on the 4th carbon. Yes.
Dr. Henry, should we have a dash after the 5-ethyl between the L and the 2 or no?
Yes, you should. Makes it clear, keeps it clarified. You don't like this part here, you don't need it. You can actually get away with just putting the space. But when you get down here with the Y and E, this part, because usually that's the N, so they always put dashes there to let us know that where it's at. Okay.
I'm just going to clarify real quick. So E is double bond and YNE is triple bond, right?
Mm-hmm.
Okay.
But when you write it like that, you drop the E on the YN.
Yeah.
What alphabetic order though?
Okay, so
The triple.
when
Like that.
when
So
I have a double bond on a side chain,
Ah, hell.
Oh my gosh.
Not today.
when I have a double bond on the side chain, it's not too bad. It's not too bad. 'Cause
Side chain bonds.
then- what was that?
Like 2 double bonds as a side chain.
Yeah, so you right now we only have a single one, right? So this guy's name now would be,
Right.
so it was where that the ethyl. So now we would just call it,
18.
so yeah, ethyl, yeah, so ETHENYL. So you still have that NYL at the end, right? Or YL at the end.
I have a question. Why is there a 4 all the way at the end where it says undecene?
Because that tells me where the double bond is at. So 1, 2, 3, 4. We have a double bond between the 4 and the 5. And since that's the main chain, it tells me, okay, on the main chain, you have a double bond.
So the bond, the number or the double bond, if it's or any bonds that are on the main chain will be put in front of
The number,
whatever.
yeah, that number there refers to where that double bond is at. Okay.
Okay.
Can there be a triple bond off of the main one?
Off the side chains, can I have a side chain triple bond? Yes. So if I have a side chain triple bond,
Oh. What do you guys look at that?
Oh.
okay. So that's my side chain triple bond. Then all that's going to do is just change that E-N-L to a Y. Put a Y there.
Wait, what?
Now,
Oh,
now I have a triple bond.
right. Because of the alkyne.
Yes.
Okay, I'm getting it.
So there's a little logic to the craziness. You know?
Yeah.
Dr. Henry.
Yep.
So right there after the 7, we just leave it as YN as the triple?
Yep.
Or do we put the E?
YN. So I can actually show you, I should show you both ways. So you want to put it just the YN there, right? The other way is you put it in the root of the last word. And so you'll have, which I don't like doing because it gets very confusing. Both of them are acceptable. One is older than the other. Let me show you, but I'll show you anyway. So, because you'll see them both written both ways.
Put the other one in the bottom. There you go.
What was that?
No, I was just asking so you can compare them.
He was trying to tell you how to teach.
No, I was
Kidding, Eric.
Dr. Henry's. That's why he's a doctor.
No.
Wait, are you rewriting for the triple bond that you just added, or?
No.
Oh, okay.
This is another way that you'll see it, where they'll actually tell you where that double bond is at. They'll put the number within the undecane. I mean, yeah, undecane. It'll actually put it within that topic. So you have undeca 7 ein 4 een.
Oh, I like that better.
So this one is, to me, is more aesthetically pleasing. And this one is like, I'm like, what the hell am I looking at, right? So, and you will see both forms on chemical bottles, unfortunately. Okay, so now these are just our alkenes, alkanes, and alkynes. We haven't even talked about the alcohols yet. Okay, so we're gonna get there. There's one more thing that I want to talk to you guys about. So if I have six, okay, 1, 2, 3, 4, 5, 6. So this guy has 6 carbons, right? So these guys, what is the 6th carbon called?
Hex.
Okay, so that would be my prefix. So I would call this guy cyclo hex ane, een, or ein.
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 A-N-E. Hexane.
Cyclohexane.
Why is it cyclo?
Why is it cyclo?
Yeah,
Why do you think it's cyclo?
Because it's cycling.
it's in a circle.
It's in a circle, that's right.
Ooh, okay.
Yep. So if you have a circle or it closes on itself, you put cyclo in front of it. There's an exception.
His exception.
This guy, where you have alternating double bonds, it's called benzene. I can spell. I am struggling today. Benzene ring.
Why is it Ben?
You know, I have no idea. I wish I could tell you. Probably
just
some
what-
guy named Ben discovered it or was the first one to isolate it. So he's like, I'm going to name it after myself. We're going to call this benzene.
So you know how the other ones are carbons? What are these ones?
These are also hydrocarbons.
Oh,
All of these are hydrocarbons because all they have in them are hydrogen and carbons.
yeah.
But for instead of going off the point, it's going off the line itself to count as a carbon, or?
Yeah, so each line, each 1, 2, 3, 4, 5, 6, each corner is a carbon. Same thing here. 1, 2, 3, 4, 5, 6. Each carbon is a. Only thing you're like, this guy is just coming on itself. So if I have a
So on that double, the last one you did with the double bonds, there's no, it's just Ben because it is, and then it's ENE because that's the double bond, correct?
yeah.
Okay.
Yes, let me know that there are double bonds in it. And you'll also see it drawn as this. They'll draw it like this in literature. They get lazy because we're chemists or scientists. They'll put a big circle in the middle, although that's ugly.
What's the circle supposed to mean?
It just means that there's double bonds and that, it's alternating double bonds. It's just letting me know that it's benzene. So it'll be
There's a
drawn
double
like that.
bond all the way around.
Yeah, because there's double bond there, there's a double bond there, there's a double bond there. You can't have two double bonds right next to each other.
On that one, is that the only one that's going to be out of, or not in our normal list?
Yeah, the only one that we're going to talk about right now. There are tons of them, but right now, there's the only ones that we're going to talk about. Don't stress, just breathe, keep breathing. It's real simple.
You drew an octagon.
What was that?
That you drew, was that 8 sides? 1, 2, 3, 4.
Octagon? Yeah, it looks like
So then what would I call that guy?
It was like a circle.
octane.
Octane.
I would call it octane.
Yeah.
Recyclooctane.
Cyclooctane. Don't forget the circle part.
Oh yeah.
I'm learning.
Sounds like a superhero.
Cyclooctane.
I'm cyclooctane.
Okay, piece of cake so far?
Sure.
Okay.
Dr. Henry,
Yes.
how do you count these cycle ones? Okay, so 1, 2, 3, 4, 5, 6. 10. Oh, yeah. It's okay, Doc. I got it.
You got it?
Yes,
Okay.
thank you.
The lines are just a little squiggled, that's why.
Hey, I'm working on it. It's hard to, you try to do this all day. Well, you guys are all critics.
Dr. Henry,
Yes.
the one with cycle in it, what do you call it?
These guys are called, they're called aromatic rings. The reason why they're called aromatic rings, that's a very general form, or you call them cycloalkanes, right? Or cyclohydrocarbons, just meaning they're circles. Aromatic rings gives you all your smells. So a lot of your ring structures provide smell, like strawberry. You guys like strawberry?
Mm.
Strawberry is a couple of these rings put together, right?
Cool.
Okay. Oops. Crap. There we go. Okay. Few more things.
You got 7 minutes.
I got 7. You're timing me?
Throwing it all at us. I need a little ready.
Okay, so let's talk about something fun. We're gonna turn up. 1, 2. Okay, how many carbons does this guy have?
2.
2. So this guy has 2 carbons. So this guy is called, this is OH. So these are our alcohols. So anytime that you see just an OH by itself, not another O or anything like that, those are alcohols. So the way that we name alcohols are, we use how many carbons there are. How many carbons are there?
2.
And we call anything that has 2 carbons in it
F.
So ethyl, and since there's single bonds, there's no double bonds, so we use ethanol. So we just put OL at the end of it.
Yeah.
That's when it has 2.
It has 2 carbons, 1, 2. Ethyl, no double bonds. So that's why we use the AN, and then OL means that we have that. That's for our OH. Okay, so alcohols are going to have an OL at the end of them. So these are alcohols.
Isn't ethanol racing gas?
No, ethanol is drinking gas. I mean, drinking gas. Drinking alcohol.
Sounds like someone's been drinking some gas already.
No, wasn't that cup?
Well, it's, it's pomegranate soda.
Sure.
Okay, so
Yeah, there it is.
what is this guy called?
Propanol.
Right?
Phenol. Capital.
You're right, propanol. 3 carbons, 1, 2, 3.
It's called E major. When our pointer's gone, we just have to start. Yes. Dude, good thinking. I like that. All right. Now you remember how to play our A chord, right? We went to our Spider-Man and we went down to
This guy.
Heptanol.
Heptanol.
That's so cool. Let me do that again. Want to show me again? Yeah. It's even better.
Okay. Piece of cake?
Yeah.
How long have you spent on practicing this?
Okay. So now this guy, this is the OH serves as a functional group. It can also be moved around, right? So let's say, for instance,
Of course.
Dr. Henry, that last one is 7 or 8?
7.
7. 1, 2, 3, 4, 5, 6, 7. Yeah. Okay, so this guy here, the longest carbon chain is how many carbons?
3.
3. So it's propanol, right? But we would call this, the common name is called iso.
Why?
It's perfect.
They separated all of them?
Sorry.
I don't
How was
know.
it 3 then?
What was that?
How was it 3? Because it has 3 carbons.
It has 3 carbons. 1, 2, 3. So we call it propo, but it's called iso because you have even sides on both sides.
Oh, okay.
Isopropanol. Do you guys know what you use isopropanol for? Not
No,
to
what-
drink.
To clean wood. I don't know.
You said to clean wounds. Yes.
I was right.
What was that?
I was
Yes,
right.
you're right. Yep.
Oh wow.
Clean rope.
I have a question.
Yep.
How come in the isopropanol, the carbon is attached to the OH on top, but in the one where it's a heptanol, the carbon isn't attached right there on the back OH? Does
Yeah,
that
the
make
carbon's right here, right? So here the carbons, there's no carbon attached to it. This is the stemming to the OH. There's no carbon at the end here. So that's 1, 2, 3. 3 carbons. On that second carbon, if there's an OH group. So it's like this. O bonded to our C, bonded to another C, bonded to another C, and then we have our hydrogens.
So we just taught you 2 new chords. But you're still going to be playing. Don't worry. Redo your circle.
Okay, that's what you have. Where this guy here, this is just attached directly to it. So that's 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon. 7 hect, right?
Yeah.
And then it's attached directly to our OH.
But right here, it's not attached directly to the OH.
No, because there's a carbon right there.
I got it.
That's why that carbon is attaching it to it. So that's the way it's looking.
Okay.
Okay.
So on the test, Doc, how would you ask this question?
What do you mean by how would I ask this question? I would say draw isopropanol.
Okay.
Yep. Show me the structure for isopropanol.
Okay.
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 Questions, concerns, Cash.
I'll
Okay.
take that.
Now on the priority list, you guys are keeping track of your priority list?
Sure.
Alcohols.
Have priority over.
Yep.
No. So the OH has priority over the bonds. Is that what you're saying? Because isn't that what the alkene and kyne and cane are for? The
Yep.
bonds.
Yep.
Okay.
So the functional group OH has priority over the double bonds and the triple bonds. And what I'll do at the end, I will give you guys a priority sheet, right? A little sheet that has all the priorities on there. So you can use it. You just need to know how to use it. Don't yawn. No yawning.
No.
Okay? You okay so far?
So, doctor, the priority stays the same, right?
The
For
priority?
alcohol, for the alcohol, is it the same?
No, the alcohol, it has priority over the double bond and the triple bond and the single bond.
Can you give
This is the list. The top of the list is the most important. What was that?
Can you give us an example? Just draw one out real quick.
Okay, sure.
To show like how you would
prioritize it.
Yeah.
So that means that this guy, or how would I name this guy, right? So this guy would be called that one's easy. But let's say we have this guy.
It would be pro 1, 2, 3.
Yeah, he's gonna hate this.
Oh, see, it's gonna fuck us all up.
What was that?
It's gonna mess us up. You're so evil.
Who, me? I'm not evil. Actually, see. This one, it doesn't matter because it would be, I guess you could have two. You could have two. So it would be 1, oops, 1 dash, oops, prop 1 in.
Why is it prop 1?
Prop 1 to tell me that the double bond is on the first carbon.
Oh, okay.
Because it could technically be on the second carbon, right?
Yeah.
So if it was here,
If you counted from the OH, it would be
Yep.
2. If you started from the back, it'd be 1. Okay.
And then that would be 2. Yep. You always start from, now you always start with the one who has the highest priority. So the OH starts at the 1 carbon in this case.
Oh, I see.
So in that case, this name would be, oops. What about this guy?
It would be pent 5 EN.
Is it pent? 1, 2, 3, 4, 5, 6, 7.
Started from the OH, so your 1 would start on the OH.
That's right. Okay. 1, 2, 3, 4, 5, 6, 7.
Yep.
What would it be?
Hept.
Hept.
7.
Hept.
Hept.
Hept 4. Wait, 1, 2, 3, 4.
So
No?
1, 2, 3, 4. That's correct. Let me number this right. So
It's the double bonds. EN. Right?
4.
Yeah.
Okay. So, oops. Hept and double bonds. So how many double bonds do I have?
2.
So wouldn't it be di?
There we go. So, but I put the number in front, right? So then it would be
Wait.
what, 4, 5?
Yeah, 4, 5.
Di.
F.
4, 5. Die.
Lord.
Dikene? Or oh wait, you already did it. My bad.
What does the 1 mean again?
Tells me that my OH is on the 1 because my OH could technically be on any of these carbons, right? We always want to get the lowest number, but it could be on that second carbon. So then it would be,
Henry,
what was that?
is that 4, 5 die or 4, 6? I don't know how you do the double bond.
Let me fix this. Hold on. Because I have too many numbers.
First double bond start at 4 and the second one should be 6.
Is it 6? I'm sorry, 6. Thank you. Yeah, I'm ready for bed. My bed's calling me. Yes, you're right. So that's 5, 6.
Hept 4.
Does that mean you're not doing lab at 7?
Your lab is nomenclature, and I haven't put it up yet. I have to make some changes because I'm incorporating your OChem.
Wait, so since we have the alcohol, you don't start the one where it says OH, you start it from the bottom?
Yeah, it starts from the bottom. That's that first carbon. So you start at the carbons.
Okay.
See, that's what was confusing me with the isopropanol.
So this lab for nomenclature that you're gonna post, it'll be due next week?
It will be due next week, yeah. But you'll have plenty of time to do it.
Okay, thank you.
It'll help you also with some of your homework.
And so the reason you're putting the 1 was why again?
Let me know that the OH is located on the 1.
Okay.
So this number tells me where that OH is. These tell me where the double bonds are.
Hey, Dr. Henry.
Mm-hmm.
So in the instance if the OH were to be in a different spot, like how you just wrote the new problem right now, so
yeah,
that would be, it wouldn't be on the 1, it would be on number 2?
1, 2, 3. It'll be on the 3rd carbon.
Alcohol takes precedence. Okay.
Yep, it has priority. So you want to give it the lowest number possible.
Lowest number.
So then we call that guy This guy's called what?
Oh, dang.
ISO something.
Not ISO. This is not in the direct middle. That's a good thought, though.
So it's only called ISO if it's directly in the middle?
Yeah.
Okay.
There are exceptions.
Come on, Alex.
Of course there. Should have known.
Chemistry. There has to be exceptions. Okay, so let's name this guy. Then we'll call it a night. And I'll see you guys next week.
Are you not going to lab?
I'll be there. We can talk.
Like,
yeah. Okay, let's go.
I have a real quick question.
Yes.
It's about the lab.
What about the lab?
I just noticed that on one of the questions was asking to use the model kit to like set up the.
Yes, you guys didn't have a model kit, so you're just drawing figures.
You're talking about lab 4, right?
Yes.
Yeah.
Okay.
I think it's 4.
Oh yeah, I guess I do have to help you with that. I told you guys I'd help you with that. So yeah, I'll be in lab.
Sorry.
That's all right.
Thanks.
Okay.
So, hex, because it has 6. 1, 2, 3.
7.
It has 7?
Yeah, because there's still a carbon attached to that. 1, 2, 3, 4, 5, 6, 7.
That's the alcohol.
Dr. Henry.
There's still a carbon in there.
Wait.
Yeah, that was my thought too, Alex. But there's still a carbon.
Okay.
So it's
Okay, remember, the side chain here is the OH, right? There's a carbon right there. Okay? So like, remember when we draw the side chains here? That's a carbon right there at the end. That's one carbon, right? But this is a carbon in that main chain. This is your main chain. You count your main chain first. 1, 2, 3, 4, 5, 6, 7. Main chain. Here, your main chain starts here. It's coming off that first carbon. 1 represents that carbon. 3 represents this carbon. Do you see it, Alex?
Yeah, sure. It's because when we were doing the alcohols, you were counting it by like the sides, and then you were writing the numbers on the tips now. So that's why I'm getting like confused a little bit.
Me too, Doctor.
I don't understand why you're getting confused. It's earlier when we were doing it, we counted the same way, right? This here is just the side chain. This is an OH side chain. This tells me there's a bond between oxygen and that carbon. That's all it's showing you. So if I put a double bond there, that's a different side chain, right? So then I would draw a double bond. I would draw okay, so that means there's a carbon there that's double bonded to that oxygen. Like there's a single bond carbon there. And remember, each of those dips represents carbons.
Okay.
Okay, so if I have, how many carbons is that?
3.
Is it 3? 1, 2, 3, 4.
4. I don't know. Sometimes I get it confused when I count, because I count the lines and then it's like the ends, and then I get confused sometimes.
Yeah,
I
you
don't
have to count the ends.
Okay, so we count the ends. Okay.
Yeah.
All right.
Okay.
I don't know why I just thought it was the sides, like the lines, like 1 line, 2 line, 3, 4, 5. That makes sense. Like why I was doing. Okay. Thank you for the clarification.
No problem. Okay, so what will we name this? I'm not letting you guys go until we name it. Captive.
Hep 4 and oh.
Beard, you're too smart.
Oh, you did? Oh, I'm sorry. Okay, let's go to the next one.
Said Hep 4.
Yeah.
Good finding it.
Three.
And keep pushing to
Oh.
advance for this.
The EN is for the double bond?
Yep.
Yeah, okay.
So if it was a triple bond,
It'd be YN or Y.
yep. Yep.